Good morning. Wow, it does work. Good morning, everyone. I'm Nick Lanneman from the University of Notre Dame in SpectrumX, and I've been working with Eric Berger to prepare this crazy schedule for you, a joint session of 6 events. We're really excited about NSF Spectrum Week, which is, of course, SWIFT starting today, the SpectrumX Center meeting, and NRDZ. We've got IEEE DySPAN that we're co-located with. We also have the National Spectrum Management Association having their conference in the same venue. And then last but not least, the NRDZ Wizard Interagency Working Group is going to have a workshop on the National Spectrum Strategy R&D Plan. Now, we couldn't get the URL for that, but we're excited about that happening on Friday. So welcome to Spectrum Week. We're starting off the week strong with the SWIFT program from NSF. And we're really grateful that John Varan from University of Nebraska has helped organize this part of the event. And I'll hand it off to John. Look forward to interacting with you this week. Thank you.
Thank you, Nick. Welcome, everyone. Good morning to NSF SWIFT PI's meeting. I'm John Varan. I'm a professor in School of Computing at University of Nebraska-Lincoln. I welcome you to the PI's meeting. During the weekend, the OG in spectrum sharing has spoken, and with the solar storm, almost all shortwave radio waves are canceled out. So the rest of the week, we're going to figure out how to use this valuable spectrum when we don't have solar storms. It's been my pleasure to organize the NSF PI's meeting. I'd like to thank NSF, especially Hussein Abu Zaid, John Chapin, and Huayi Day for trusting my team in organizing this meeting. Also from UNL, I'd like to thank Lisa Mopin, who's our event organizer, and Sangwon Shin, one of my PhD students. He's actually around. There he is. And also SpectrumX team. If you think spectrum sharing is hard, try organizing a conference with 6 co-located events and sharing rooms. So I want to thank specifically Nick Lanneman, Josh Tullis, and Emily Case. I'm sure I'm forgetting other names, but the team is phenomenal, so thanks for all the help and support for this event. This is our morning program. We're going to have opening remarks by NSF, followed by our keynote speaks, and then we'll have a keynote panel. I'll provide some more details about the event afterwards, and then we'll kick off the lightning videos and then the poster session after the lunch. Some logistics. We are in Madison. This is the room with the star on it. Our poster session will be next door in Adams. And in the order of urgency, these are some of the landmarks you want to know. This is where the coffee is served. This is the fire escape. So when you get out, take a left and left again, and then the restrooms are here. So without further ado, it's my pleasure to welcome our dignitaries from NSF, starting with Don Millard, who is the Deputy Assistant Director in the Directorate of Engineering.
Well, thank you. So good morning. It's interesting. We should have had the door back there, I guess. But anyway, I want to thank John for all the work involved in getting this together. And I'd also like to be able to thank my colleagues at NSF for being able to arrange all of this. And of course, it's not just Spectrum Week, but it's NSF's support for Spectrum and the wireless research and education that we invest in over the years. And, you know, as you know, NSF's SWIFT program invests in future technologies to enable the effective utilization of sharing of the spectrum. You know, I hearken back to when I was a kid, and I think I was 8 years old when my dad got me my first single crystal radio set and such. And I look back to today, where we are today, where we're looking at, you know, we were just talking real time versus analog, real time digital synchronized communication. And being a double E, I now look at the world today very different. I should say recovering double E, because, you know, I'm now a politician, I guess, or a bureaucrat, I guess is the word. But I look back and I see the world today, and it's just a tremendous era of opportunity. And I think, obviously, the folks in this room have a great appreciation for what wireless and communication is actually doing to change our society and make our lives so much richer. You know, SWIFT focused on challenges such as mixed signal hardware, secured and or verifiable systems, spectrum use, innovations through AI and machine learning, and coexistence between terrestrial and satellite systems. And we now have a successor program called Next Era of Wireless Spectrum, New Spectrum. And that's supposed to, once again, be able to support fundamental research for new spectrum access, for management approaches, and to be able to deal with underlying technology enablers to be able to allow us to extend our capability. And, you know, I look at this meeting as providing a really fantastic opportunity for all of you to interact with each other and gain new understanding and insights and collaborations, and most of all, the collaborations. And so as you spend the time this week together, I really think you want to be able to look at not just what you're doing in terms of your research today, but how you might be able to come up with teams and be able to put together proposals for potential future NSF investments. And if you don't participate in NSF research, we certainly encourage you, there are a number of program officers in the room right now, to be able to work on NSF panels as a reviewer, because the best way to be able to learn about how to be able to write a proposal that could be successful to NSF is to serve as a reviewer and be able to understand living in the world that people are looking at. NSF's recent investments in wireless really are impacting many different sectors. And for example, we have an engineering research center in precision agriculture, Internet of Things for precision agriculture. I think it's IoT for ag. And it's developing agriculture-specific communication technologies for rural settings with really poor broadband. And we're looking to be able to take and relay data from, in essence, sensors in the field to be able to improve farming equipment and be able to access autonomous robots that will allow us to be able to save on both energy and water, a precious commodity. We also have another ERC called the ERC for Smart Streetscapes, and it's forging livable, safe, and inclusive communities through real-time, hyper-local technologies for streets and their surroundings. It's actually very interesting because they're being built on advancements in edge cloud technology, wireless optical engineering, and computer security. But the real key to the smart streetscapes is to be able to look at how you be able to design and address community needs for privacy, for transparency, and of course, equitable access. And so this is really trying to be able to look at means to be able to enable everyone to not just have the opportunity to be able to get on the internet and be able to use resources, but to do it in a fair and equitable way. And then we have the Broadband Wireless Access and Application Center. It's an NSF Industry University Research Cooperative Center, now UCRC. And it develops cost-effective and practical solutions for topics of interest to its members, such as massive multiple input, multiple output designs, blockage-resistant millimeter wave communications, and spectrum sharing for heterogeneous wireless systems. As you know, NSF supports projects for advanced wireless through programs involving engineering, computer science, the geosciences, the physical sciences, interdisciplinary, and translational with TIP research that goes on. So we're looking for investments today to advance cutting-edge technologies that are critical to our future generations of communications and networks. We're hoping that they'll provide a backbone for connecting users, for devices, for applications, and of course, services that will continue to enrich America's national and our economic future and our health. NSF also invests in building a future STEM workforce. And we're really looking to you to help us diversify our workforce. Frankly, right now we're missing a good portion, and we call this the missing millions of society entering STEM. And wireless is exciting. The opportunities that you have, we can actually encourage folks to be able to actually pursue degrees in technology, but more often be able to be creative through being able to do new types of design with technology that really allow you to be able to get that aha moment when something works. That's exciting, and we want to be able to engage those students in opportunities that allow them to be able to actually have successful careers. And clearly, wireless is going to only continue to grow. Spectrum's only going to continue to grow. So in closing, I really want to provide my thanks to all of you who are dedicated to exploring the frontiers of wireless research and being able to not just explore the research, but being able to put it into practice. This is really critical, obviously. The sessions this week are going to provide you with, I think, a fertile opportunity to be able to learn from each other, be able to gain new insights and such. And I truly hope that you actually take the time to be able to talk with your colleagues in the room and the spaces, to be able to look at how you might be able to develop new proposals that NSF can invest in the future. Most of all, I want to encourage you to have fun. Enjoy yourselves, be able to share your knowledge with each other, and continue to be able to improve our wireless, our communication systems. Oops, sorry.
It stipulates 5G transmission limits based on interference potential. Our team has designed a 4-element array with reconfigurable 24 gigahertz and beam steers, as well as the implementation of the ability to measure antenna clearance.
Geez, if I'd known I could do that, I would have just turned it on and then leave. Yeah, it's a Spectrum. Yeah. Anyway, look, in closing, I just want to say thank you all for attending, and on behalf of NSF and the American people, we appreciate all that you're doing to be able to further our nation. So thanks very much.
Thank you, Dr. Millard. It's also my pleasure to invite Dr. Ellen Zegura, a fellow Yellow Jackets, and also the division director from the Division of Computer and Networking Systems, CNS, within SAIS.
I should perhaps explain the Yellow Jacket reference. I'm not sure how many people will know what that is. I'm a rotator at NSF, and my home institution is Georgia Tech, and Georgia Tech is the Yellow Jackets. So let me add my welcome, add my thanks to John for the organizing, and to the student who I'm sure did an awful lot of the work. Thank you. And also want to thank the PDs that have worked on this program, and my colleagues also at NSF in leadership. This program brings together multiple directorates at NSF. And as I've spent the last 9 months in my position, I've learned just how much complexity and interesting conversation happens behind the scenes for these multi-directorate programs. I think when you're a PI, you know, the solicitation shows up, you skip over that part where it says which of the directorates are contributing funding, and you jump right to what are the problems being addressed, where can I fit, right? It turns out that the part that ends up with those names and those directorates on the solicitation is just a huge amount of behind-the-scenes work. And one of the things I've really enjoyed in my time at NSF is trying to put together and understand the puzzle, which is how cross-directorate programs come about. And this is a cross-directorate program exactly because the intellectual problems are cut across. We could not run a program like this within size alone without, we would not have a program of the richness that we have, that you're seeing in SWIFT and its predecessors. So this is a really fantastic partnership across the federation and with NSF as engineering as a key partner. I was going to tell a story not about getting my first single crystal radio, but about I think my first experience with congestion. When I was growing up, I grew up in Maryland, and some of you are old enough, at least, that you could have had this experience. Many of you are way too young, but there was a radio station called Q107. Anybody heard of Q107? Probably not. So they would run a contest when they played Hey Jude by the Beatles. If you were the 107th caller, you would win a prize. When they played Hey Jude, you couldn't get a dial tone on your phone. And I remember when the first time in my EE undergrad education that I got exposed to the reason why that would be, right? It seemed sort of crazy, right? Every time you pick up the phone, there's a dial tone. Why is it that when Hey Jude is playing on the radio, you can't get a dial tone? Now I know why. So early example of congestion and of scarce resources, right? That's what spectrum and spectrum management is about. It's about managing a fixed resource. We cannot make more. There are only a few things in the world that you can't make more of. Actually, they tend to be natural systems. Anything you can engineer, generally speaking, we can make more until we run out of the natural resources that we've relied on to make them. So it calls for creativity and shared resources. We have issues of fairness, and so it's sort of all the fundamental problems that we often work on in systems and in engineering, and in this extremely real-world context. So I've done some work myself on wireless, I don't tend to go to the layers of radio, but still we can't ignore them when we do anything in this space. One of the things that I really like about this problem space, and I think Don alluded to it, is it matters to everyone. It matters if you're in a crowded urban space. You care about what the quality is of the wireless, and that wireless problems are challenging in dense areas. They also matter tremendously in rural areas. This is a space where I've done some work myself. So the challenge of trying to provide connectivity in rural areas really depends on creative use of spectrum. So it's a problem space that it's not for the top 3%. It's really for everybody. Everyone cares about having good connectivity. So I'll point to just one investment by NSF that might be of interest to you, and that is our power platforms for doing advanced wireless research. These are test beds. They are spread around the country. They each have different focus areas, but in fact, to complement some of the ERC work that Don talked about, we have wireless platforms that are dedicated to agriculture, and rural connectivity. We have others that are have different emphasis areas, for instance, in the density of New York City. So if your work reaches a point where you would find it helpful to experiment on a power platform, I hope you will look and see which ones might be suitable for you, and we have supplements that we can award to help you take the work that you're doing and experiment with it on these power platforms. All right, I think I'm going to stop here. Great to see such a great set of folks out here in the audience, and I hope you do enjoy the week and have many productive and interesting conversations. Thank you.
Thank you, Dr. Zigura. Next, we'll have Hussein Abu Zaid, who I know many of you will know, is the program director at CNS. Let me load your slides.
Okay, so thanks. Thanks, John, and for organizing this. Thanks for Nick, is he still here? Also for somehow putting together all these events in 1 week. It's super exciting. And also all the people who helped with organizing this week. So I don't have a lot of stimulating stories about congestion or single crystal radio, because I have a few things, a few slides here that I want to just focus, basically a few announcements for this community regarding opportunities for wireless spectrum research and education. So, okay, so first is just we've been doing spectrum sharing for about, or at least wireless spectrum research for maybe 10 years, starting from 2012, where we launched the EARS program, Enhanced Access to Radio Spectrum. And that program actually launched in 2012, but it took, I was actually at NSF during my first tour in 2010. It takes just a long time, as Ellen mentioned, to actually design a program and put everyone together. But that was the first program that had multiple directorates joining forces to focus on spectrum research. So we had SIZE, engineering, MPS, and SBE primarily for that program. And then that program became SpecEase in a few years, and then SWIFT, and then SwiftSat, looking at non-terrestrial and coexistence with terrestrial networks, and passive and active coexistence, and so on. So, so now what's next? Okay, so next is, of course, a new program, and that has been announced, and the deadline for that is May 28th. So please put your best teams together and best ideas forward. We want to highlight a few things about this program that we're asking you to have a perspective about the next era of spectrum. So please do read the solicitation. The solicitation describes one way to look at the history of spectrum sharing. So it presents a view of 3 previous eras, the sort of anarchy until 1910, and then the beauty contest approach, and then the third era was the auctions, where the government was very happy to make money. But now we're out of spectrum, so we need a new approach, and that we call that new approach Spectrum Era 4. And we have a supplementary information in the solicitation that describes different views of and citations of some previous recent work and particular perspectives of what Spectrum Era 4 could look like. And we ask you to either propose one or adopt one of the vision perspectives from the solicitation. And you need to have a section that says relationship to proposed research to Spectrum Era 4. Okay, and that's very important, and that's a must. And you know that must is something in solicitations where if you don't do it, your proposal gets returned without review. Right? So please give this some thought. Okay, and if you have questions, of course, the team of PDs, many of them are here. So please ask questions. There is also a webinar that was recorded by John Chapin, and it's posted at the solicitation page. So it goes through the solicitation and explains why things are there and highlights different aspects of what your proposal needs to address. So please also take a look at that webinar. We also have a workforce development. This DCL is still open. This also involves a number of directorates. This is not a hard deadline, but we ask you to submit your proposal by June 10th if you want it to be considered for this budget year. Okay, and this is really a good opportunity for you to submit proposals. The proposals are in the form of supplements, and if you have an existing award, any of these qualify. So if you have a SWIFT award, if you have a RINGS award, if you have a NERDS, if you have an award in any of the core programs that is related to Spectrum, so that includes the size core, SPECIs, and so on, you can submit a proposal on Spectrum STEM. So that's preparing the next generation of Spectrum workforce. And there are many ways you can, different types of proposals. You can write a supplement for a graduate research student. You can do an REU. Conferences, workshops, each one of these has their own guidelines in the DCL, so you can read it. It has its own budget limits and so on. So please take a look. Okay. And then the last thing I have is a bunch of announcements as well. One is many of you are familiar with the RINGS program. So the second RINGS PI meeting is hosted by IBM July 9th to 11th. You can register at the RINGS VO, so rings.vo.org. You can go there and register for online attendance. You can also request in-person attendance. In-person is primarily for the PIs and the sponsors, the partners for RINGS, but you can also request there if you wanted to attend in person. The PI meeting, as you know, is about the PIs presenting updates on their projects. This is the second year. This is the end of the second year of the RINGS program. But also the workshop will be of interest to the general community, because there will be also some discussions about the future opportunities, future research, maybe what should come maybe after RINGS, because RINGS is a 3-year program, so all the awards will end next year. Another thing is Ideas Lab, called Breaking Low, Breaking the Low Latency Barrier. So this is a program, a solicitation. This has been launched by TIP with participation from engineering and SAIS. And the preliminary proposal due date has passed, which is April 18th. But the full proposal is September 30th. And in the full proposal, the PIs who will participate in the Ideas Lab workshop can also if they're invited to submit a full proposal, they can invite people who maybe did not even submit preliminary proposals. So you need to maybe stay in tune with the community as well to see if you can participate. And then the third is actually not an NSF opportunity. This is another government agency, NTIA, and our colleagues there have announced the second call for proposals, which is called NOFO in their terminology, Notice of Funding Opportunity, which is like a solicitation. And this is for open radio commercialization. So this is, we want our community, we want the academic community to be aware of this. And there are two tracks. There's the open RU commercialization, and then there's the research and development. And research and development is particularly of interest to the academic community. The awards there are, I believe, in the range of minimum 5 million and up to 10 million per award. And the total budget for this is 420 million. So there's a lot of funding that will be awarded in this, and it's also wireless focused. It is maybe higher TRL levels. It's maybe not very basic research. You can read the solicitation because it describes what research and translational level. Was that me? Okay. So please, there is also an informational session on May 17th, and you can register for it. And that's all I have. So thanks again, and hope you enjoy the rest of the day.